इसके अंदर कुछ रजिस्टर्स हैं, हम कहते हैं कि इसके अंदर ALU सर्किट है, हम कहते हैं इसके अंदर कंट्रोल सर्किट है। शॉर्ट में हमने ऐसा कह दिया। फिर हमने कहा कि प्रोसेसर है तो 3 तरह की बस के साथ इसका एसोसिएशन है, ये कंट्रोल बस है, डाटा बस है, एड्रेस बस है। फिर आगे फर्दर हमने कहा कि ये जो बस है ये बस एक भी हो सकती है, ये बस मल्टीपल भी हो सकती हैं। उसके आधार पर हमने कहा कि अगर हमारा एक सिंगल बस अगर इसमें है तो सिंगल बस आर्किटेक्चर को फॉर्म करता है, सिंगल बस कंप्यूटर ऑर्गेनाइजेशन को फॉर्म करता है। हमने कहा कि मल्टीपल बस अगर एसोसिएटेड हैं तो ये मल्टी प्रोसेसर ऑर्गेनाइजेशंस को भी फॉलो कर सकता है, मल्टी बस आर्किटेक्चर को भी फॉलो कर सकता है। सो दैट इज बेसिकली द डिजाइन ऑफ द सेंट्रल प्रोसेसिंग यूनिट। सो व्हेन वी कम, जब थोड़ा सा और आगे बढ़ते हैं, क्योंकि सेंट्रल प्रोसेसिंग यूनिट इज बेसिकली द प्रोसेसिंग एलिमेंट ऑफ द सिस्टम। Since it is the processing element of the system, so each and everything whatever we want to calculate by the system, that is going to be calculated by the CPU, that is going to be calculated by the processor या processor organization. So when we talk about the processor organization, we further discuss that 4 type of organizations we generally see. That first of all we see the stack organization are there. So whenever we talk about the stack organization is the organization which basically works onto the principle. That principle is known as the last in first out or first in last out. That in short can be known as the LIFO principle, last in first out. So stack is basically the data structure, and we want to say here that whatever the processor designing at today, they generally internally follow the stack organization. Means to say they work onto the principle that is last in first out. Not even processor hardware follow the stack organization. Even the software also follow the processor organization. Means to say whatever the programming languages you seen today that work onto the principle, that principle is known as the last in first out. In the previous class we discussed about the one of the example that whenever we pass the argument inside any of the function, even when we are talking about the C language, the execution of the argument of the functions are going to be occur by using the stack organization. So one of the general organization is basically known as the stack organization, and most of the processor today follow the stack organization. Second organization, we see that second organization is the accumulator organization. You can say that is the single register organization, in which we are saying that some of the processors are available where the single register is efficient to do all the mathematical calculations within the system, and that register is basically known as the accumulator register. So the single register organization also known as the accumulator organization, where we use only a single register for performing the calculation within the CPU. Third and fourth, whenever we talk, these are the two organizations. One is the 2-register organization and another is the 3-register organization. But both combinedly, both are known as the general register organization. So whenever we talk about the 2-register organization as well as the 3-register organization, we said that these two organizations are basically known as the general register organization. So we see that whenever we study this processor organization, the central processing unit, the general register organization is there, the stack organization is there. Then after that, whenever the processor organization is there, the instructions are being executed within the system, within the CPU, then every time whenever we want to execute the instruction address is going to be required. So we are saying that every instruction having some of the standard format. So who defines the standard format? In general, the standard format, the format is going to be defined via the instruction, that what the input we are passing through and what the output we are getting. So what the input is there in the instruction and what the output we are getting, as well as whenever we are passing the instruction within the system, that what exactly the operand we have applied onto the instruction. So these three things combinedly refer as an instruction. So this is the instruction format, which basically contains the input operand, output operand, and operator. Next is, whenever the instruction is present with you, for performing calculation with the instructions, we have a requirement to find out the address of the instruction. So there are multiple addressing modes have to be defined for calculating, for generating, for evaluating the address of any of the operand. So lot of addressing modes are available there. Next, whenever the addressing modes are there, we have to discuss that the data transfer is going to be occur within the register. So data transfer and manipulations we have to discuss here. And since the next instruction address is always contained by the program control, so PC is a register which contains the address of the next instruction. And finally, we are saying that your system, whatever the system you have today, that is based on the reduced instruction set computer. But whenever we go back up to 40 year, 30 to 40 year, we see the size of the computer was very much large, and at that time the computer followed the instructions that were known as the complex instruction set computer. So we will study both type of architecture, that the architecture is there, that is reduced instruction set computer, and another architecture is there that were known as the complex instruction set computer. So two type of architecture in general we will study, and these two type of architecture are RISC architecture, that is the reduced instruction set computer, and CISC architecture, that is the complex instruction set computer. So now onward. We have discussed earlier about that, but we are repeating this so that more clarification generated regarding this whole thing. So what we said, whenever we talk about the CPU, we generally see the three components are basic at there. One is known as the registers, another is known as the ALU circuit, third one is known as the control unit. So these three, with the collection of three type of buses, the three type of buses is data bus is there, control bus is there, address bus is there, is basically form a CPU. So we are saying here the register itself is known as the storage component, the ALU is itself known as the processing component or execution component, and the control unit is also known as the control component, and the buses are there, and that buses are basically known as the transfer component. So this is basically the processor organization. Is it okay?
Yes, sir.
So these four things, register, ALU, control unit, and all three type of buses, control buses, address buses, data buses, form the processor organization, form a central processing unit. Next, in basic computer, there is only one general purpose register, and this general purpose register is basically known as the accumulator organization, accumulator register. In modern CPUs, there are many general purpose registers, and right now we very well know that we are using the modern CPUs. So we said earlier to you that every system always contain some of the specific registers, such as the register names are A, B, C, D, E, H, L, accumulator register, PC register, instruction register, MAR register, memory address register, memory data register, etc. So lot of registers are available within the CPU right now. So it is advantageous to have many registers. So we are saying that whenever we take the multiple registers within the CPU, then it is always advantageous since it becomes the faster of the calculations, but always take the register as per the requirement. If the problem is very small and we are taking large number of registers, then the speed of execution may be decreased also. So transfer between register within the processor are relatively fast. So going of the processor to access memory is much slower. So we are saying here how many register will be the best. So it depends on the requirement of your whatever the expressions you want to evaluate. So general register organization. So whenever we talk about a general register organization, we said the register is there. Suppose the 8-bit register, that is the R0 to R0 to R7, a register is available. Here basically the 7-bit is representing in the diagram. Suppose we have the 7-bit or 8-bit register, and each and every flip-flop in the register generates a 1-bit, work onto the 1-bit. These bits are connected via using the bus to the multiplexer, and these multiplexer sending the output to the ALU circuit. And within the ALU, OPR means we want to apply any of the operator onto the register content, and finally we are getting the output. So this type of organization where we are saying that register content, register value via using the bus, transferring onto the multiplexer, and from multiplexer the data is going to be transmitted onto the ALU circuit. ALU basically perform the operations onto the register value, and finally after performing the calculations and transferred the output to the again another register or memory. So this type of organization is basically known as the general register organization. We said this all type of calculation can only be feasible whenever the clock pulse are applicable there. So whenever the clock cycle is applicable there, clock pulse is applicable there, then only the calculations can be performed.
सर सर इसमें
पूछिए।
डिकोड काम है सर।
डिकोडर का काम है डिकोड करना, जो भी आपका जो कोड है उसको डिकोड करना. सो दिस इज द अनदर बस, ठीक है ना. दे मे बी द सिलेक्शन लाइन डी, देयर मे बी द अनदर बस व्हिच कैन परफॉर्म द डिकोडिंग ऑफ द कंटेंट. So encoder is there, decoder is there. Encoder circuit is hide here. So encoder circuit is there, decoder circuit is also available there. Operation of control unit. So whenever we talk about the operation of the control unit directs the information flow through arithmetical logical unit via selecting various components in the system, as well selecting the function of arithmetical logical unit. So whenever we write the example that R1 assign the value R2 plus R3, we want to add the content of register R2 and the content of register R3, and we want to store this addition in the another register that is basically known as the R1. So what exactly we want to do? The multiplexer A is there, that is the selector, that is select A. So whatever the operations we have to do, Suppose we want to perform R2 plus R3, then first of all we have to store the content of R2 onto the any bus. So we are transferring the content of register R2 onto a bus, and that bus name we have taken, that is the bus A is there. So bus A is getting the content of register R2. Again, we have taken the another bus, the bus B is there, and that is storing, that is fetching the content of register R3 onto the bus again. So bus B contains the content of R3. Then we want to perform the operation, that is the selector is there, ALU operation selector is there, and we want to perform the addition operator is there. And whenever the addition has been occurred, the decoder circuit come in action. So the decoder destination circuit is there, selector is there, that is cell D is there, and whatever the output is come, that by using the decoder circuit go onto the another register, that is known as the R1 is there. So whenever we define the control word, the three things are there. One is basically the input unit is there, another is the output is there, third one is the operation is there. So input we have taken through bus A as well through bus B, and output taken onto the D, that is the selector line or decoder line, and operation that is going to be represented here in the circuit via the OPR. So this basically defines the control word. Now encoding of the register selection fields. So whenever we want to talk about the encoding scheme, this encoding scheme can vary from system to system. So a demo encoding scheme has been given at here, that initially the binary code is 0 everywhere, the input A is there, selection line A means to say bus A is there, selection line B, bus B is there, and selection line D, that is another bus is there, that is the decoder bus is there. So the encoding scheme may be anything, but sequentially it has been represented that 1, 2, 3, 4, 5, 6, 7, since 8-bit register is there, 0 to 7, the 8-bit register is there. At initially input is nothing, so the input, and output is nothing. So whenever there is no input, there is no output. Simply has been shown here. Whenever the output selection line A contains R1, selection line B contains R1, the selection line D also contains the R1. Simple has been shown up here. The selection line 2, that is the R2, selection line B again contain R2, the output is again R2 is there. So like that, this has been given at this place. Again, encoding scheme of the ALU operations. So operation selection line is there. Maybe depends that how many bits register we are taking. So here we have taken the 5-bit register. So operation selection generate the data of the 5-bit data. May be possible whenever you take the operations within the system, it may be 32-bit register or it may be 64-bit register. So whatever the data will be generated here, that will be of 32-bit data. And whenever we talk about the operations, the multiple operations can be occur within the system, such as transfer A, increment A, addition, subtraction, decrement, and or XOR, complement, shift right, shift left, arithmetic shift right. So lot of operations are available and multiple operations can be occur at here. So one of the another symbolic designation has been given for the ALU micro operations.
सर ये ऑपरेशन सर किस बेस पे लिखे हुए हैं सर? ऐसे तो सर याद करना पड़ेंगे ना, ये समझने
ये याद नहीं करने हैं आपको, ये सिर्फ डेमो के लिए दिखाया गया, ये पेपर में आएंगे नहीं कभी। सो इंटरनल सर्किट कैसे काम कर रहा है, तो इंटरनल सर्किट में ये बताया गया है कि जब आपका ऑपरेशन हुआ, ठीक है ना, तो 5 बिट का यहाँ ऑपरेशन दिखा दिया। कितने बिट का दिखा दिया कि जैसे एनकोडिंग ऑफ ALU ऑपरेशंस वी आर सेइंग कि 5 बिट के ऑपरेशन हो गए, 5 बिट में कवर हो गया, बट ये एग्जैक्टली वेन एवर यू विल टॉक अबाउट द सिस्टम, ये आपका जो सिस्टम होता है आइदर 32 बिट सिस्टम आप यूज करते हैं या 64 बिट सिस्टम यूज करते हैं. Right now you are using the 64 bit system, so this data will be generated of the 64 bit. Is it okay? So this data will be generated of the 64 bit. So it is not a so easy task, it is a very complex task. Is it okay? So this is for demo operations has been shown here. Such type of occurring will be occur within the system, and this will be represented whatever the system you are using, how many bit system you are using, that data will be generated accordingly that. So it will never be the 5 bit data, it will be the data of 32 bit or 64 bit data. So that is very difficult to manage and very difficult to write onto the answer booklet. So this is only for knowing that how the ALU circuit is performing the operations, what type of representation is going within the system. So whenever you save your any of the file within the system, and if you see the machine code of that particular file, then you will see a very complex data come at there, such as you have executed the C program, and whenever you open the C program, yani whenever you execute the C program, the 3 files will be get created. One file you created, that is the a.c. Another file, whenever we compile it, get created, that is known as the .o or .obj. If you are using the Unix operating system, then this is .o. If you are using the Windows operating system, then it is .obj. Correspondingly, one backup file .bak will get generated. As well, final, whenever we get executed this program, we got the .exe file. So total 4 files are presented in that situation. Whenever you see that .obj file, you will see, you open that file in the notepad, etc. You will see that machine instructions has been generated. That is basically the combination of 0 and 0, 1, 0, 1, etc. Still some of the functions are there which is not converted into the machine instruction. We will later on know about that, why these instructions not get converted into the machine instruction. So basically we are saying that machine instructions has been presented here. That is the encoding of the ALU operations, and that is very complex to define, and this may vary system to system. You got it? And finally, whenever we talk that we said that register stack organization is there, I already told you the 2 type of stack organization is there, one for software, another for hardware. So whenever we talk about the stack organization, either we are talking about the software stack organization or for hardware or memory stack organization, we are saying that whenever the stack organization is there, the stack organization always work onto the last in first out principle. Always work onto the last in first out principle, or we can say onto the LIFO principle. So stack organization is very useful feature for nested subroutines, nested interrupt services. Since right now the latest languages you are studying, such as C, C++, Java, PHP, Python, etc. In general, these languages don't contain the word subroutine. The subroutine were present here in these languages in the form of the functions. So we are saying a very useful feature for nested functions, also efficient for arithmetic expression evaluation. Remember always, you have a gate examination. You can give the gate examination after completion of the MCA, and stack organization question always come in the gate examination, and this question is coming from last 20 years. So we are saying stack organization is very important organization to understand. So first of all, it is very necessary that we have to know that stack organization is the organization which works onto the last in first out principle. Second thing, in the stack organization, we can perform the two type of operation. One is known as the push operation, another is known as the pop operation. Whenever we talk about the push operation, the push operation is basically known as the insertion in the stack, and pop is basically the deletion in the stack. So whenever we perform the insertion operation, then we check the memory for overflow. Whenever we perform any type of insertion operation in the memory, we always check for overflow. And whenever we want to perform any type of deletion operation in the memory via any of the data structure, we always check the memory for the underflow. So basically we are saying the stack may be either empty or either full, and this depends then what the operations we want to perform. So a stack pointer basically represents the top of the stack. The stack pointer always represents the top of the stack. So push operation is there. So whenever we want to perform the push operation, first of all we have to go for the empty memory and we have to increase the stack pointer value by 1, and then after that we have to assign the value to the stack pointer memory, and we are saying in the push operation, first of all we are increasing the stack pointer value by 1, and then after that we are assigning the data register value to the stack pointer. And we are saying if stack pointer equals to 0, then full equals to 1 and empty equals to 0. Whenever we talk about the pop operation, means to say we want to delete the values, then first of all we have to store the content of the stack pointer to any of the data register, and then after that we have to decrease the stack pointer value by 1, and if stack pointer value equals to 0, then empty equals to 1 and full equals to again 0. It is basically known as the push and pop operation and on behalf of the software applications. Whenever we talk about the memory stack organization, the push and pop operation just become reverse, and that is the definition of the memory stack organization. A portion of the memory is used as a stack with the processor register as a stack pointer, and push, that is stack pointer assigned the value stack pointer -1, that is memory at the stack pointer store the data register. That is the push operation, that is the just reverse operation to the software stack. And pop operation, first of all, data register contain the value of the stack pointer, and we increase the value of the stack pointer via 1. So we are saying the most computers do not provide hardware to check stack overflow, that is the full stack, or underflow, that is the empty stack. So this can be done at the level of software, that can be done, that is the must be done in the software. So we are saying that whenever we talk about the stack organization for the memory, that is for the hardware, then in that situation, lot of hardwares are present in the market which generally never provide the underflow or overflow concept within the memory itself. So in that situations, we are saying that whenever you want to implement the stack through programming, then in that situations, always you have to write the overflow and underflow coding within your stack programming. Next is reverse Polish notation. So we are saying that three type of notations, we can represent any of the expression via the three way. Either it is basically known as the infix notation. Whenever we write the simple expression such as a plus b, then it is known as the infix notation. Whenever we write plus ab, it means it is the prefix notation, or also known as the Polish notation. And whenever we write ab plus, then it is basically known as the postfix notation or reverse Polish notation. The reverse Polish notation is very suitable for stack manipulations it has been said here that postfix notation is always follow the stack organization. So whenever we want to evaluate any of the arithmetic expression via the CPU, then automatically internally the system convert this into the form of the stack, or we can say into the form of the reverse Polish notation, and reverse Polish notation directly evaluated by the stack organization. तो अभी मैं इतना ही रखते हैं हम आज का. एनी क्वेश्चन अप टू हियर यू कैन आस्क मी. मेरा एक ही लेक्चर है ना आज.
सर फ्लैग्स के बारे में बता दीजिए.
किसके बारे में?
फ्लैग सर स्टैक में था